The Pythagorean theorem states that on a right triangle, the legs, or the shorter sides, squared, will equal the hypotenuse, or the longer side, also squared, as you can see in this diagram. The equation we use when we use this theorem is a squared plus b squared equals c squared. A and b represent either of the legs, while c represents the hypotenuse. This theorem was created in ancient Greece by a mathematician named Pythagoras. Pythagoras created this when he noticed the relationship between the sides of a right triangle. But that's enough history. Here's an example of how we can use this in a real-life situation. This is Jimmy. Say hi, Jimmy. Hi. Now, Jimmy was having a normal day in his apartment building when, all of a sudden, BAM! His house was on fire! The only way Jimmy can escape is through his window. Jimmy's window is 20 meters off the ground, and his ladder needs to avoid a meter-long pothole. Jimmy needs a ladder that can go through this dotted line. How do we solve this? We'll use the Pythagorean theorem. We already have the information we need to solve this, with 20 and 1 as the legs. Since they're the legs, we're going to use them to substitute a and b in the equation. According to PEMDAS, we're going to have to square them first, which they equal 401, and when added up, they equal 401. So this means the answer is 401 meters, right? Right? Wrong. Keep in mind that 401 is supposed to equal the hypotenuse squared, so we're going to have to find the square root of it to find the answer. The square root of 401 is about 20.02, so the answer would be 20.02 meters. Now that we know this, little Jimmy can now escape the burning building using a 20.02 meter long ladder. Saving Jimmy is probably giving you a good insight on the Pythagorean theorem, but I should probably inform you about something else called the converse of the Pythagorean theorem. The converse states that on a right triangle, one of the legs squared is equal to the hypotenuse squared minus the other leg squared. So basically it's just the same thing backwards. Here's another example that will help you understand this a little bit better. Look at this lamppost. You're trying to figure out how tall it is based on this info. The distance between the top of the lamppost to the top of the shadow is 5 meters, while the distance between the bottom of the lamppost and the top of the shadow is 3 meters. Using this info, we can figure out the height of the lamppost. We're going to plug in 5 for the hypotenuse and 3 for one of the legs. First we square the values, which gives us a squared plus 9 equals 25. Then we subtract 9 from both sides, which gives us a squared equals 16. Then we take the square root of 16 and find 4, meaning a equals 4 meters. So, now we know that the lamppost is 4 meters tall. But seriously, why do we need to know the height of this thing so badly? Anyway, you know about the Pythagorean theorem, and now you know the converse. But there's one more thing I need to tell you, which are Pythagorean triples. Now you're probably wondering, what the heck is a Pythagorean triple? Well, it is a set of integers that can form the sides of a right triangle. These numbers can include sets like 3, 4, 5, or 7, 24, 25. These also include multiples of these triples, as long as they're multiplied by the same number. These triples can easily be used to solve Pythagorean theorem equations. For example, if we were to go back to the light post problem, we could easily figure out that the light post was 4 meters tall just because it was a Pythagorean triple. So, now that you've mastered the use of this theorem, you can easily become an architect, or a mathematician, or an astronomer, or you can even make an instructional video for other kids. Anyway, I hope you learned something. Thanks for watching.